We are doing section 4.2. Nope. I already did 4.1 yesterday. We do, or yeah, I guess it was yesterday. We do. Yeah, that was it for 4.1. It was pretty easy, wasn't it? All right, so now I'm going to give you 4.2. So remember I said yesterday, I said it was free of charge, and I said I wouldn't charge it to you. What was that? Do you remember what I was talking about then? Yeah, but we talked about any triangle.
All angles is 180 degrees.
Very good. Okay, remember that? So if I had a triangle, which I have a triangle right here, and if I added up all the angles, we'll call this angle 1, angle 2, and angle 3. So if I added them up, angle 1 plus angle 2 plus angle 3, it doesn't matter what kind of triangle. It can be an acute, it could be obtuse, it could be right, it could be whatever you want. All right? If you add up all three of those angles every single time, it's going to come up to what? 180 degrees. It is. It's a theorem. I'll show you why it's a theorem. It's a good question. Okay? So watch. We're actually going to do a little proof on this. All right? So let's not use this triangle. Let's use one that... Nah, it doesn't even have to be a right triangle. But let's use a triangle that the bottom of it just goes straight across, just to make it a little easier for us.
Oh, man.
All right? And let's take this to here. What I'm going to do is I'm going to do a little proof of this, because Taylor had a good question. She says, why is this not called a postulate? Why is it called a theorem? Well, what's the difference between a theorem and a postulate? Right, a theorem can be proven. That's correct. And a postulate, what do? Just accept it as fact, okay? Take a pass. So you just accept it, right, as fact. All right, so this is actually a theorem. It's on the... Now again, I don't really care about the numbers of the theorems. They call it Theorem 4.1 because it's chapter 4 and it's the first theorem. Okay, but not every single book do they call it Theorem 4.1. So I never make you memorize these theorems by the numbers of the theorems. But they call it, let's write it down, they call it the triangle. That's a good start, right? The triangle angle sum theorem. Again, not every book calls this theorem this. All right, this is probably, that's supposed to be a U. Yeah, you could call it sum of the triangle theorem. That would be fine. Okay. Again, this is just a name that this particular book came up with, and
think of how much the people who made this book have no life.
They got no life. Well, this is their life. That is I guess that is a life. So watch. So if I call this, actually, let's not do that. All right. You with me so far? So we call this triangle angle sum theorem, or we'll call it Chris's theorem, which is the what? What do we say? Didn't you say it? The angle sum, the triangle, the sum of the triangle theorem, I guess. All right. Either way, it doesn't make any difference. You get the idea, don't you? That all the angles add up to 180. Let's do a little proof of this. First of all, what we're going to do is we are going to draw an auxiliary line, which means it's a line that's really not included in this, but we're going to use it to help us out. So what I'm going to do, I'm just going to draw a line right here. Let's drop it down just a little bit so it touches. Now, what do you think? Now, I purposely made this line, what do you think, to this line right here? Parallel to each other. Okay? So watch. This line right here, there's a lot of little talking. Austin, please. So these two lines right here are parallel to each other. Agree? All right, because I made it that way. All right, so I drew an auxiliary line. So what I'm going to do is put some angles in here. They call this angle 1. This one is 3. This one is 2. This one is 4. And this one is 5. Okay? Now watch. What I want you to do, I'm not going to go through exactly the steps in the book for the proof. I'm just going to kind of do it a little bit more general. All right, so just, it's in the book if you want to. It's on page 244 if you want to see every little step and every little reason. Okay, I'm basically going to go through the whole thing, but I'm not going to be real particular that you put this step in this order and all that kind of stuff. I just want you to see what's going on. Now, just looking at this right now, what we want to do is we want to prove this thing right here. This is what we're trying to prove. That those three angles, angle 1, angle 2, and angle 3, add up to 180. Now, how do we know that? Just because I told you they add up to 180? Or just because somebody else, you know, in your earlier career, math career, told you that they add up to 180? We need to figure out why they add up to 180. All right, so we're going to do this by this proof. We put this auxiliary line that's parallel to this one, and we name these other two angles right here. Now, what can you tell me about angle 4 plus angle 2 plus angle 5? How do you know they equal 180? We have a reason. Because it forms a straight line. It forms a straight line, right? Okay, so these three angles form a straight line, which means a straight line is how many degrees? A straight angle, which is 180 degrees. All right? There's several things you have to say to make that work, but as far as we're concerned, 4, 2, and 5 all add up to 180. Why? Because they form a straight line. Agreed with that? All right. Now, what's up with the parallel lines? How in the world does that help us here? Well, let's take a look at angle 4. See? Angle 4 is part of this, isn't it? Let's take a look at angle 4. Is there something that you can tell me with the parallel lines? Is there something you can tell me about angle 4? Yes, there is. Look at it. Alyssa, what do you think?
Is it equal to the other angle?
Give me a number.
Angle 1.
Why is it equal to angle 1?
Because it's alternate interior.
You got it. Exactly right. You see that? So look, 4 and 1 are equal to each other, aren't they? Look, I've got parallel lines cut by transversal. The alternate interior angles must be equal to each other. You with me so far? All right, so I've got this one arc with angle 1. You see it? So let's do something else. You see something else very similar to that? Very close to that? Alex, what do you think? 5 and 3 are equal to each other. Does that mean 5 and 4 are equal? No, not necessarily. All right, but 5 and 3 are. We're going to put 2 arcs there. You with me? All right, so what do I know? I know that angle 1 equals angle 4, and I also know that angle 3 equals angle 5. Are you seeing anything? Again, what are we trying to do? We're trying to prove this, aren't we? We're trying to prove that angles 1, 2, and 3 add up to 180. I can look at 4, 2, and 5 and say they add up to 180 because they form a straight line. Why in the world do 1, 2, and 3 add up to 180? Because of this. If 1 and 4 are equal, look, what can I change that to? Angle 1. So watch. Let's bring this down here. So instead of calling this angle 4, let's call it angle 1. Well, angle 2 is just angle 2, isn't it? All right, I don't have to mess with that, so I can just put angle 2. What about this? Angle 5. What's angle 5 equal to? It's equaling angle 3. So watch, I can put angle 3 right here. Check it out. What's all that equal to? What's my reason for that? Why can I replace angle 4 with an angle 1? It's substitution. Very good. The substitution property, all right? So it's by substitution. And look, what did we just do? We just proved something. What did we prove? That the sum of the angles, let's write it like this, okay? I'll say this every once in a while. The sum of the angles of a triangle, right, equal what? 180 degrees. What does sum mean? Addition, a total when you add them up, okay? So it's the total when you add them up. The sum, when you add up all the angles of a triangle, they're always equal to 180 degrees. And we just proved it. Now, they have a nice formal, well-written proof in the book. All right, you can look at that if you want. It's on page 244. We mentioned that earlier. But this is kind of more of a free-flowing right, kind of example of a proof. But that's basically what we just did right there. We proved that angles 1, 2, and 3 are 180 degrees. Isn't that cool? All right, let's pause this and we'll move on. All right, here we go. Here's an example. Here's a couple triangles, right? Actually, 3 of them. Do you see it? Do you see 3?
I see 2. Yeah, I see 2.
I see 3. I see dead people. Right, the 2 little ones in the whole thing, right? So look, this is angle 1 and this is angle 3, this is angle 2. So it doesn't mean it's 1 degree, 3 degrees, 2 degrees. It's the number of the angle, all right? Now, I'll do the degrees in a different color. Let's go to this nice, beautiful purple. And let's say this is 57 degrees. You probably can't even tell the difference between the colors, can you? Up on the screen. On the computer, you can. That's 28 degrees, and that's it. It says find the measures of the numbered angles. All right. So let's see. Well, this is 57. This is 71. What do you think the first one is? We're going to find. We can find a couple of them pretty easy. You could find angle 1. Okay, let's do angle 1. How would you find angle 1?
Just be 180 minus.
That's right. It's 180 minus 57, right? Do you see that? Because it forms a straight line? Yeah, that's pretty easy. So you didn't have to learn anything new today to figure out angle 1, did you? All right, so what's that? That's a 3, and that's a 2, and that's a 1. Did I do that right? So that angle is 123 degrees. So that's 1, 2, 3 degrees. Actually, I meant to draw that in black, but there we go. All right. Very good. Now, we should be able to find 2 and 3. 2 we could have found right off the bat without even knowing 123, right? But let's take a look at these and look at this. What did we just learn? We just learned that the sum of the angles of a triangle are what? 180 degrees. So what are we going to do with all 3 of those angles? Add them up and set them equal to 180. So angle 2 plus what? 57 plus 71 equals 180. Everybody got that? Now look, you don't necessarily have to go through all this. What do you do? You just add these up and then, so add them up. What's that? That's an 8 and that's a 12. 128. Did I do that right? 180 and then subtract it. Alright, so angle 2 is equal to, what's that, 52 degrees? So that's angle 2. That's right there, 52 degrees. We good? Alright. What about angle 3? It's right, same exact thing. So angle 3 plus 123 plus 28 equals 180. So angle 3 plus, that's a 1, that's a 5, that's a 1, right? Equals 180. Subtract 151 from both sides and you get, what, 29? Is that what you said? Angle 3 is 29 degrees. So that's 29 degrees. Did I do that right? Yes, I did. Okay. Now watch. I want to show you something that leads us into the next. This is a good example because this leads us into the next little theorem that they have. Let's see. Yep, it is a theorem. So what I want you to see is this. Look at this. We said this was 20, or sorry, let's do this. Look at this 57 right here. Okay? And then look at this angle, and then look at this angle. Tell me something. They're almost the same? Look at these two and what they do. They add up to be 57, don't they? Do you see that?
Yeah.
Look, these two right here actually add up to be 57. Is that just some kind of magical thing that happens? No, not at all. All right, it actually just works out real nice, and we'll show something a little bit later. Look at 123. Tell me something about 123 and a couple other angles.
71 and 52.
That's right, 71 and 52 add up to 123. Do you see it? You guys listening, right? Becky, please, come on, up here. I'm in the middle of saying something. Girls? So watch. This is 123 out here. I want you to recognize something. Do you see this angle and this angle? These are the three angles of this triangle. This angle is outside this triangle, isn't it? We call this angle an exterior angle. We've talked about exterior angles earlier, right, in another chapter, didn't we? Alternate exterior, alternate interior, remember that? Okay, so look at these two. These are interior angles because they're inside the triangle. We call these two remote interior angles. What do I mean by remote? Like if you live way out in the woods and there's nobody around, you live in a remote place, don't you? You're away, you're far away. Remote control. Remote controls are great because you can be what? Far away from the TV. I grew up back in the old days when we actually, get this, hold on to your seats, we actually had to get up off the couch, walk over to the TV, and actually click the channel. Can you imagine such horror? So anyway, okay, we're running out of time, hush. So anyway, that's remote. Remote means far away. You follow me? So look at this 23. This is an exterior angle. These two are remote interior angles. Not this one, because this one's right next to it. It's adjacent to it, isn't it? That's what next to means. This is remote interior angles. So let me just do one little quick thing in 45 seconds and we'll be done. Okay, here we go. We got a situation. Angle 4 would be called what? Exterior angle. Okay, 1, 2, and 3 are interior angles, but what would you call 1 and 2? We would call them, what was my little story? Remote interior angles. So what do you think the theorem says? The theorem says that the exterior angle is equal to the what? The sum of the, no, not just the interior, but the remote interior angles. All right? That's it right there.